molecules of elements and compounds. Atoms of some elements exist independently. In some cases, two or more atoms of elements combine to form molecules. So, some elements can exist in the form of a single atom or monoatomic, while some elements may form diatomic molecules like oxygen, nitrogen, etc. When atoms of different elements combine with each other, they form compounds. Molecules of these compounds are formed by the chemical attraction between elements. Students, you now know how atomic mass is calculated. You can use this table to know the atomic masses. However, for practical purposes, we require to know the molecular masses of the substances. How do we find the molecular mass? The sum of the atomic masses of the atoms present in a given molecule is the molecular mass of the substance. Molecular mass of water, or H2O, can be calculated as follows. Hydrogen has an atomic mass number 1 and has 2 atoms in its molecule. The total atomic mass is equal to the product of the atomic mass and the number of atoms. Thus, total atomic mass of hydrogen is 1 multiplied by 2, which is equal to 2. Similarly, oxygen has an atomic mass of 16 and it has 1 atom in its molecule. Hence, the total atomic mass of oxygen is 16 multiplied by 1, which is 16. The molecular mass is equal to the sum of the atomic masses of H2O. Thus, we have atomic mass of hydrogen multiplied by 2 added to the atomic mass of oxygen multiplied by 1. When we substitute the values, we have 1 multiplied by 2 plus 16 multiplied by 1, which is 2 plus 16 equals 18. Atomic masses of common elements are as follows. Carbon is equal to 12. Oxygen is equal to 16. Nitrogen is equal to 14. Calcium is equal to 40. Chlorine is equal to 35.5. Magnesium is equal to 24. Sodium is equal to 23. Molecular mass and mole concept. When elements or compounds react with one another, it becomes necessary to know how many molecules or atoms are taking part in the chemical reaction. For this, a new concept of mole was introduced. What is a mole? 1 mole of a substance is equal to its atomic mass or molecular mass expressed in terms of grams. For example, the molecular mass of oxygen is 32. 1 molecule of oxygen contains 2 atoms and the mass of each atom is 16. 32 grams of oxygen is equal to 1 mole of oxygen. One of the most well-known scientists, Avogadro, experimentally found that 1 mole of any atom or molecule always contains 6.022 into 10 raised to 23 atoms or molecules. This number is called the Avogadro number, denoted by N0. Avogadro defined a mole as a collection of 6.022 into 10 raised to 23 number of atoms or molecules, just as in daily life we use the words like dozen or 12, century or 100, gross or 144, etc. Let us see an example to calculate the number of molecules present in 42 grams of nitrogen. Given, the atomic mass of nitrogen is 14. Solution. Nitrogen is a diatomic molecule. Thus, the molecular mass of nitrogen is 2 multiplied by 14, that is equal to 28. The number of moles of nitrogen is equal to the mass in grams divided by the molecular mass of nitrogen. Therefore, we have 42 divided by 28, which is equal to 1.5 moles. 1 mole contains 6.022 multiplied by 10 raised to the power of 23 molecules. Therefore, 1.5 moles will contain 1.5 multiplied by 6.022 multiplied by 10 raised to the power of 23 molecules. Similarly, we have 1 mole of oxygen molecule corresponds to 6.022 multiplied by 10 raised to the power of 23 number of particles, that is, atoms or molecules or ions, which also corresponds to 32 grams of oxygen. When molecular mass is expressed in grams or G, it is called gram molecular mass. Similarly, when atomic mass is expressed in grams, G, it is called gram atomic mass or gram atom.